Welcome back, Dalen, with another random making encounter, and today it is again part 2 on fun with LEDs. Now, part 1 was really a quick deep dive, and there's a link, not even a deep dive, a shallow dive actually, and there's a link somewhere, into the world of electronics. What are some of the terms? What are some basic concepts, so that if you've never done this kind of stuff before, you have some terminology that you might understand. Today, what we want to do is look at actually building and using some simple LED circuits. And how do we go about doing that? The first thing I do want to talk about, though, is let's say you don't want to do any soldering at all. You don't want to do anything that requires any real additional tools. You want to kind of just buy stuff off the shelf. There's a couple options. There's a few options. Option 1 is there are sets that are made, components that are made by usually railroad terrain or railroad scenery companies like Woodland Scenics, not an endorsement, but Woodland Scenics, that have lighting kits. They have power blocks, lighting that you plug in, switches, power supplies, all of that good stuff. And you can kind of build and mix and match a modular system to suit your needs. Those are great. They work. They might be overkill for a lot of what we're doing. And so when you're thinking about your lighting setup, if that feels like too much of a thing, there are some other options out there. The first thing that really comes to mind, and a lot of these are just kludging around with things that already exist. The first thing that comes to mind are these little mini votive candles, and they come in all different shapes and sizes and price points. Some are really cheap, and they're plastic, and they've got a big flame, that kind of plastic flame that sticks up. Those would be actually pretty nice. They don't have to be very believable. This one's actually, I think, wax coated, and it's supposed to be super believable. They do not need to be, because all we're interested in is the light in them. So you can actually just build your thing around them. You could actually break these apart or deconstruct these a little bit and just use sort of the guts. There's a bunch of things you could do with them, but there's a bunch of tutorials out there that show you how to make like flame effects with cotton balls and things that look like billowing smoke and campfires, or signal fires, and you can use these to great effect. They're super inexpensive, they work really well, they're very believable, and they just have a great flicker effect to them. So these are sort of the easiest first thing to potentially grab. In a similar vein, a little bit more light available to you are things like these battery-powered fairy lights. These, again, inexpensive. They're intended for parties where you need a bunch of them for centerpieces, and they come in these long strands. Now, the cool thing about this is you can actually cut off individual LEDs, and you can use those LEDs as standalone LEDs. Whoops, wrong direction. So you can use them as standalone. You could cut a couple of them off and use them as standalone. Whoops, wrong direction again. So we can use these as a source of very tiny, almost sort of grain of wheat LEDs, or you can just use them as a strand with their original setup, put them in a house, put them in a vehicle. If you don't need one, like these could be your headlights, some towards the back could be your tail lights. If you don't need things in between, you could paint them out. You could mask them out with some electrical tape. You could cut it down to just the lights you need. But these are really handy. Again, very inexpensive. They usually come in bulk because they're intended for centerpieces for parties. In a sort of next evolution or iteration of that are things like these color changing RGB lights. And the way that these, what these are really for again, putting in, these are actually waterproof, so they're intended to go in flower arrangements in the base of things where they might be submerged. And then, you can change the colors to match the mood of your party. And they also have some additional things like color changing effects where it fades or transitions from one color to the next. These are cool because they're not a single color. And so you're able to use these to sort of bring some additional storytelling potentially to your set piece, to your terrain, to your gaming. And so you could say, initially it's a green pool and, you build a pool around it. you craft around it your pool of wisdom, and then as your characters approach it, if they do something wrong, it becomes the pool of doom, and you can change the colors and you can do some storytelling with them. The nice thing is they don't have a single color, and you can actually mix and match and kind of fine tune whatever it is you're trying to light. All of these could literally just be dropped into buildings. You could drop this in a building, you could drop the votive into a building. As long as you're not playing with the interior of the building, slap your roof on top and you're ready to go, and you've got some lighting built in. Really easy to use, completely standalone. Those are sort of some of the things that are commercially available. So you want to think about, well, what's out there in LED lighting that I can just literally kit bash? I can grab it, I can bend it to my will, I can use it for my own purposes. Now, the next thing we want to talk about are, okay, so let's say some of these commercial off the shelf don't work for me. Well, what's my next option? The most sort of flexible option is to actually just start to use straight up LEDs, build your own circuits, and build your own setup so that you can have exactly what you want. The right location, the right intensity, the right colors. And we're going to start really, really simply with standard LEDs. Now, the thing to keep in mind is there are a lot of LEDs out there. There are flicker LEDs, some candle LEDs that exist. So this is a nice, gigantic, big flickering LED. Here's another one. This doesn't have the diffused sort of element to it, but this one is another flickering one. This particular manufacturer has several different colors. So this is sort of the amber color. There's sort of a red orange, I believe, and there might be one that's even more of a red. You could actually combine these together to great effect to get a really nice, rich range of colors in just a couple LEDs. There are standard, regular old colors. Green, they come in different sizes. Red, so this is a little bit smaller. Red, yellow, all sorts. This is a really tiny little guy. Tiny, wrong direction, tiny. So really tiny little LED. They also come in RGB cycling, so this will slowly cycle from red to green to blue. So there are some that cycle color. There are UV LEDs that you can use. So that could actually be very, very cool if you were using UV reactive, either like inks or paints. So those could be black-like paints, so you get that fluorescent, or it could be UV so that when you actually turned the light on, it was transparent to begin with, and then it reveals something as the UV hits it. So there are some sort of UV, like, spy ink kind of paints and things that you could write or draw with, and then have a UV light hit it in part of your set piece as well. Lots that you can do. This is a UV light. I've got it sort of plugged in because this coin cell wasn't quite enough to drive the UV. And I'm going to actually just pull that so it's not shining up in the camera. The thing that really you want to keep in mind is that there are a lot of LEDs available to you. So there are some assortment kits out there. You can buy them. You can buy them as packs of LEDs. So you want to sort of look for the ones that are going to best suit your needs. There are cool white, there are warm white LEDs, there's just a ton of them out there. Now, once you've sort of figured out what LEDs you want to use, another thing you want to think about is how are you going to integrate that into your model, your kit, your thing that you're building, your terrain you're building. A lot of times it's really super inconvenient to put them where they need to go because you're really space constrained. So a couple things to think about are light pipes, so things that are called light pipes. And really this is just some clear acrylic rod. So let's say I have some place I want to get an LED light to, but I don't have the space for it, but I could run a long line to get the light to it. So by taking a piece of acrylic rod, and I've just sort of hit it a little bit with some heat to sort of melt the tip of it, This will pipe the LED from its source to the end of the rod. So I can actually deliver my LED lighting a distance without actually having to get this right where it needs to be. So light pipe is one. Very, very similarly, fiber optic, you can buy this, you can buy coils of this stuff. Fiber optics are the same thing. I can have an LED source, and I can have my fiber optic, and I can deliver a pinpoint of light using the fiber optic. Now, one thing that would be cool with like fiber optic is, let's say you have a treasure hoard in your thing. You could actually drill really, really tiny holes in the treasure hoard, in amongst the coins and gems, and you could run fiber optic in through a variety of those points, and then you could have an LED that creates a twinkling, sparkling effect. And I'm thinking of doing a tutorial on just that. So if you're interested in that, make a comment below down in the comments to say, dude, go ahead and do that. I'd be interested. But the idea with fiber optics is, again, taking a light source and piping it to a really, really specific spot that may be inaccessible to the LED itself. All right, so light pipes, fiber optics, and then LEDs that are available to you. Okay, so now we want to build some custom circuits. We've got the commercial off the shelf sort of figured out, but we need to do something a little bit more specific to our project. So we need to build some basic LED circuits, some basic LEDs. How do we do that? Well, the very first thing that we want to do is we want to figure out what our power supply is. What is our voltage that we're going to be using? There are a bunch of different ways you could do it. You could use coin cell, like a coin cell holder if it was really tiny. You could move up to something that's a little bit larger in a battery pack, a 2-cell that might be running around 2.8 to 3 volts. Something like these 4-cell that are going to be these are rechargeable. So these are 1.2 per battery. So this is around 5 volts. This is a little bit closer to or over, depending on the battery charge, how fresh they are, around 6 volts. So we want to decide, is it battery driven or is it power supply driven, like these wall transformers? This is a 5-volt wall transformer. Now, I have a lot of 5-volt transformers because when I get into microcontrollers and using microcontrollers to control RGB LEDs, they're 5-volt systems generally. So it's nice to just start there. And I want to build things that I want to plug in, flip the switch, leave it on, and enjoy, and not have to worry about recharging or replacing batteries. So think about what your power supply is based on your application. If you're trying to cram it into a mech, into a model, you might have to go with something as small as a coin cell. Now, an interesting thing to note about coin cells is they do have, if I were to crack this open, there are no resistors. There's no resistor in this to help regulate the amount of power going to these LEDs. Coin cells generally have enough resistance built into them. They don't deliver a lot of juice that you can actually connect them directly, and you don't run the risk of burning out your LEDs. So coin cells are sort of a unique case in that they're not delivering enough power to really require the use of a resistor for the most part. And that's how we can use them to test LEDs like this. So coin cell, but if we're sort of stepping it up, then we have to start to think about resistors and how do we calculate and build the circuit. Now, the good news is the web handles all of that for us. There are many sites, and I will post a link to one that I've been using in the description, that have LED resistor calculators. So that's all you need to type in your search bar, LED resistor calculator, and you'll get all sorts of options available to you. Now, what I've got here is a little breadboard. So breadboards are a way to build test circuits. Basically, there's power on the sides, positive and negative, and then each row is connected. So this is all connected. And so we want to make sure that when we're connecting things, we're actually spanning rows. We're not connecting things to a single row, because that's all one big line of connections. Can I say connection one more time? Pretty repetitive in these things. Now, what I've got here is This is about 6 volts. It's actually a little bit more because these are fairly fresh batteries. So this is a little over 6 volts, and it's just plugged in. I've got a capacitor here for no real good reason, but just because it looks cool. And I've got 2 LEDs wired connected in series, and I'll talk about that in a minute, and just one standalone little old green LED all happy by itself. Now, when we go to our calculators, they're going to ask for a few different things. The first thing it's going to ask for is what is the voltage of your system? In this case, we're going to type in into the little field, calculator field, 6. It's a 6 volt system, nominally. If I had this one, I'd type in 4.8. If it was the power supply, 5 volts. You get the picture. The next thing that it's going to ask is what is the forward voltage of the LED? Okay, I don't know. There are some cheat sheets usually in there that says, well, if it's a green LED, it's this. If it's a red LED, it's that. If you buy LEDs, they'll come with either a spec sheet or you can look up a spec sheet on them. In this case, this big macro bag O, box O LEDs has all of the information I need provided on the inside. So in this case, it says the green LED, which is what we're going to calculate for, its forward voltage is 2.8 to 3.2 volts. Well, okay, thanks for giving me a range. I kind of hate you for that, but I'm going to go somewhere in the middle and call it 3 volts forward voltage. The next thing you need to know is what is the forward current of the LED. And in this case, it tells me, so it says 20 milliamp. Some of these are 30, but the cheat sheet on the website usually says, when in doubt, 20 is a good number to plug in. The final thing it's going to ask for is the number of LEDs. And in this case, we're going to type in 1. You hit calculate and it's going to spit out a diagram and it's going to tell you what your resistor value is for your given circuit. Now, I'm going to use some colors here because it's always fun to draw with colors. And what I'm going to do is I'm going to say my LED is blue and the LED has a positive and it has a negative lead coming off of it. We'll draw a little line here. Boop, boop. Okay. And so what we're going to do is we're going to basically connect to our power supply, our positive part of the power supply. Here's our battery. We're going to connect it to the LED. And then this is the diagram, it sort of spews out. And then there's a resistor. And it has color code, some bands, and then that goes to the negative terminal of the battery, the power supply, whatever it was we're using. And in this case, it's 6 volts. Now, when you hit calculate, it's going to say, okay, here's what it should look like. Connect the positive to the positive, connect your negative to the resistor, and then connect that to the negative of your power supply. Okay. It calculated a number, I want to say out of the box, it says something like 180 ohms. Now, an ohm is also a big, gigantic creature in Nausicaa, Valley of the Winds, I believe. That's not the same kind of ohm. It's not related at all. But ohms are a measure of resistance. And so in this case, we don't need to get into what an ohm is. All we need to know is what color are the color bands that we have to look through thousands of LED or thousands of resistors to find with a microscope, if you've got tired old eyes like I do, to find the right resistor. Now in this case, we're going to start with 220 ohms, which is red, red, brown. And then gold is the gold colors, the metallic colors are how accurate they are. So generally resistors, electronic components, especially resistors, have an accuracy amount. So if you need super precise amounts of resistance, you need super precise, sort of high quality, high accuracy resistors. These gold ones are sort of the standard sort of run-of-the-mill accuracy. I don't know if it's plus or minus 5%, but that's what the gold color is for. So red, red, brown, magically calculates out to 220. So now when I plug this in, basically the way this LED is plugged into the breadboard is this little orange jumper goes to the negative row of the LED, and then I'm going to plug using the resistor the power into the positive. So I'm a little backwards in my schematic, but that leads me to an important little point. In basic circuits like this, it does not matter where the resistor lives. The resistor can live over here, the resistor can live over on this side, and in these simple circuits, it doesn't matter. It provides the protection to the LED. So I'm going to plug that in, and I'm going to get my little green LED light. It's pretty bright, and actually looking at it, I'm getting sort of a little bit of a retinal burn, but this is sort of almost full intensity on the LED. It's pretty bright because we're actually sitting at a little bit more than 6 volts here. The actual calculated resistance for this was about 180. I'm a little bit higher than that, but because I've got more voltage coming in and I'm kind of guessing on that forward voltage, I'm kind of saying it's somewhere in between. This is pretty intense. Now, let's say that we want to be a little bit kinder and gentler to our LED, and we don't want to drive it at full intensity. Well, the simple thing to do is just to go to your resistors and pick a higher value. So I'm going to go to 330. I'm going to plug that in. Let's see what that looks like. I don't know if you can tell in the video, it's a little less damaging to my eyesight. It's definitely looking like it's not really just cranking at full intensity. And this would actually be, if I were to look at this, to me this feels like a better value when using batteries that might be driving a little bit more than 6 volts. So I'm not really taxing the LED to its full extent. So 330, I mean, that's a lot. 180 to 330, that's pretty significant. So what that tells me is in these cases, the difference in for resistors, if I've got a calculator and it's telling me I need a certain value, I don't want to go lower than that value, but I got a lot of slop above that value. Let's pull this and let's go to 1,000 just for grins and plug that in. And you can see, again, a little bit dimmer, but really we're looking at 220 to 1,000. It's still perfectly usable. It's still got a lot of intensity and brightness to it. And so I don't need to be spot bang on my resistor. So if you buy a kit, a bulk pack of them, and you're like, it says you need, 180, and you've got your choice is 150 or 220, you're not going to choose the 150. Grab the 220, but you could also grab the 370 or the 470 or the 1.5, 1,500, right? You can grab some of these higher values, plug them in, and see how they work. You'll get to a point where once you get way, way up there, you'll actually start to see enough dimming that it might not be what you want, but we'll show that actually with these white LEDs. So the bottom line is you don't want to go lower, but you can go significantly higher and still get perfectly acceptable results. Okay, so that's a single LED. Now, what does that look like soldered up? It's pretty straightforward. Let me find it here. Okay, here's what it looks like. The way I would do this really simply is take my LED and solder to one or other of the connectors. It doesn't matter which one the resistor goes on. I would solder the resistor directly to the lead. Simple as that. I would make sure that I know which lead I'm soldering to because it does matter polarity, which one gets the red wire versus which one gets the black wire. But where this resistor lives doesn't matter. Okay, I'm going to move it here so it's kind of in the clear space so that you can see it. I'll solder the red wire now to the resistor, and then I'm going to get a little piece of heat shrink tubing, and I'm just going to slide that over it, heat shrink that down. I can do that after all the soldering's done, but I am going to cover that lead with heat shrink, because what I don't want to have happen is I don't want these to get pinched and short. So I'm going to slide that up over it, heat shrink that down, and protect that lead. The next thing I would do is I would solder the black lead onto the negative lead, or the black wire to the negative lead of the LED. Get a little bit bigger heat shrink tubing, slide that up over the whole shebang, and shrink that down. And then I'd have a really nice, compact really tidy LED that I could put in my model. I could snake it to my building. I could put it wherever I want it, and it would be really, really clean and super cool and great and awesome. Now, if I plug this in, these are actually calculated to 5 volts. So I'm going to go on this side of the breadboard. I'm going to plug it in, but you can see there's my LED, and it works super spiffy and it's awesome. And you could just make a bunch of these things and just have have your leads, figure out the length of wire, and then just run them in, mount them, and then run them all back to your power supply, and you're good to go. All right, so that's a single LED, super easy. Okay, now let's get a little bit more complicated. What if we have 2 LEDs or more? This is where it starts to be more variable in how we might build the circuit. So in this case, when I plug all the values in for the 2 white LEDs, what it gives me is a circuit that looks sort of like this. 2 LEDs. And this is where the first video we talk about wiring in parallel versus wiring in series. My red is starting to croak on me here. Poor little thing. These are the little leads coming off, little leads. Okay, so here's my power supply, whoop, positive. Here's my, I'm gonna connect, basically I'm gonna connect the positive, and then I'm gonna wire them in series. So my positive connects to the negative, then this negative is gonna connect to a single resistor, and then it goes to my ground. Now, so basically these are connected. And that's what I have here. So if we were to look at how this looks connected, if I keep flicking things around, the long leads are positive, the short leads are negative. So these would be positive, negative, negative, and then the resistor. So hopefully that makes sense. Now, the way that this calculates out for 6 volts is it says it needs about 1 ohm resistance. That's not a lot, considering up here we were talking 180 to 220 was our starting point, 1. So I'm going to plug in 1 ohm. It's because by adding more LEDs, the LEDs themselves end up sort of dividing voltage. They impact the voltage and the current, and so you're actually needing less resistance the more LEDs you add. It gets weird, and I'll show you in a minute what that means. Again, pretty intense. These are pretty bright. So 1 is a little bright. Let's just jump up to 510. Let's just go straight to 510. Plug those in, significantly dimmer. Let's go 1,000 times, go up to 1,000, and fairly dim. Now, for your model, maybe you don't need high beams, right? You just need your driving, your fog lights, or your low lights. You could crank in, you don't need to pay attention necessarily to what that minimum number is. You can push those up above, but the calculator is going to give you your starting point. Now, that's 2 LEDs, 6 volts, based on all the specs for the LEDs. Now, where it could get more complicated is you might end up plugging in your numbers, and you might say, I have 4 LEDs that I need to drive. And what you may end up with is something that looks like this. Here are my LEDs. There's our leads. Hopefully these drawings are not too weird and confusing. Positive, 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 positive. Negative, 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 negative. So, okay, we basically have one of these already. I'll show you, I actually forgot to show you what that looks like soldered. So I'll jump back to that. We have one of these, but 2 rows of it. Then it comes out and it connects to our battery, positive, connects to our resistors, and now we have 2 resistors. Okay, and depending on the battery, the power source, or the voltage, and all of your number of LEDs, your forward current, your forward voltage, you will get a variety of different circuits that will be your optimal circuit to run your LEDs. And then this goes to your negative. So in this case, we basically have wired sort of in parallel two pairs of two LEDs that are wired in series. And so that's where this parallel versus series terminology becomes important to understand. Up here, we're connecting the LEDs positive, negative, so positive to negative, and then we're adding a resistor, but we're running them in parallel. And so this would be a 4 LED setup, and it will vary. You go to 6, you go to 8, you go to 5, you have odd numbers. You're going to end up with all sorts of interesting, weird combinations of series, wired in series, and wired in parallel. And a lot of it has to do with the way that voltage drops across the LEDs in order to get enough power to them correctly. So hopefully, if you understand the general concepts from the first video and then you can look at those diagrams, it will help you understand how to connect your lighting. Now, what does that look like? So in this case, what I've got is two LEDs. So this is what a constructed version of the two white LEDs. So let's say I have a little light bar in the top of my thing, or I've got some lighting on my spaceship or something that I need a red and a yellow LED. I can basically connect on them. So this red wire indicates that I've connected the resistor to the positive lead of the red LED. I've taken the negative lead of the red LED and soldered it to the positive lead of the yellow LED. Following me so far? And then I've soldered the black wire, the ground wire, to the negative lead of the yellow LED. Again, I would slide some heat shrink up over those to protect them from shorting against this wire here. Heat shrink that down. And then if we connect these two bad boys up, plug those in, we have our red and yellow LED. Now, one thing to note is these LEDs actually have very similar forward voltage, forward current requirements. When they are different, and they will differ by color, blue is a little bit different. When they differ, you're going to have to sort of play a little bit of guessing game, and you might find that you'll have some variation in sort of the intensity of the LEDs, and you might have to play with them a little bit. Again, always err sort of on the side of more resistance than less in your resistors. But again, you can sort of mix and match a little bit to varying degrees of success. And so if it gets too weird and wonky, then your next option is to just go to something like this, where you have each one, if they're so different, you can just wire them individually and you don't have to try and put them into the same circuit. All right, so there we have it. Like, that is sort of the basics of creating LEDs, wiring them up, hooking them into batteries, hooking them into other circuits. Now, one thing I wanted to show you is let's plug in this. I'm going to put the high resistance version of this in, and I'm going to basically pull the plug on the power. So this has a capacitor in it, and the capacitor has stored some amount of energy. So watch the LEDs. There are two of them, so they're going to draw a fair amount of current, but watch when I pull the power. You can see that they slowly dim. Now, because there was a fair amount of resistance on them, they're still not completely out. What's happening is we're draining the power out of the capacitor, and the LEDs are slowly dimming. Higher capacity capacitors can actually run LEDs for a fairly long period of time before they all completely dim. But that's sort of a demonstration of how capacitors are a reservoir of energy. All right, well, I hope that was actually helpful. There's a lot to unpack there, from how to use stuff off the shelf to actually how do you start to solder up your own LEDs and build your own LED circuits. If you did find this useful, press that like button, click that like button, subscribe to the channel, follow me on Instagram, all of that good stuff. The very next video that we're going to do is going to be talking about using microcontrollers to control RGB controllable pixels. And so we're going to use some microcontrollers, we're going to use some NeoPixels, and we're going to really bring it to the next level. But this is really approachable and doable for the average person with a soldering iron and a few basic components. So thanks for watching. I hope you made it to the end. We'll see you back for another video real soon.